It is not really long ago that you started writing your first voting contract, a very simple, elegant way for users to propose ideas and let others vote yes or no. That was your first step into the on-chain world. But today we're taking it to a whole new level. I am Sneha from the Web3 Compass, and this is day 28 of 30 days building with Solidity. Apologies for day 27. It was a little bit of mess, but Screen Studio application had some errors after we recorded the entire video. The file was corrupt and we could not really recover it. The support team needed its time to do it. So I really hope that by the time you're watching this video, day 27 is up too. So I know you have two videos to look into and a little more than usual work that you might have to do today, but yeah, bear with us. It is not really long ago that you started writing your first voting contract, a very simple, elegant way for users to propose ideas and let others vote yes or no. That was your first step into the on-chain world. But today we're taking it to a whole new level. Just 2 more days when we wrap up 30 days of Solidity. So today, we will be discussing about decentralized governance. As of now, in the real world application sections, we have been discussing a lot of things about DeFi, automated market maker, lending pool, yield farming, and all of that. And now we need to get into governance. So now, everyone who enters Web3, they might have heard of this jargon term called DAO. So let me just tell you what DAO really is. DAO stands for Decentralized Autonomous Organization. It's a new kind of system where the community, not a company, runs the show. No CEOs, no managers, no lawyers drafting contracts behind closed doors. Instead, everything happens on chain, transparently based on the community's decisions and votes. Now imagine an online club where everyone who holds tokens, gets a say in the decision making of the club. Like what happens, what are the kind of events, what are the new book reading sessions that we want to do, and everything. So all the major decisions also around how funds are spent, what features are built, or what upgrades happen, everything is voted on. Once a vote passes, the smart contract automatically executes the decision without waiting for human approval. Now that is what we call as pure democracy, written in Solidity. If you ever heard of projects like Uniswap, Aave, or Compound, they're all governed by their communities using DAO systems that run just like the one you are about to build. Now, what makes it different from our initial voting contract that we have written? Okay, so when you built your simple voting system earlier, you learned how to collect votes, decide outcomes. Today's project really adds real world complexity, but in a very beginner friendly way. Like, still, we are keeping up the beginner friendly style here. In this upgraded DAO system, users will lock a small deposit when proposing an idea to prevent spam. Voting power will depend on how many tokens someone owns, meaning bigger stakeholders have bigger voices, etc. Proposals must meet a quorum, a minimum level of participation to be valid. Even after proposal wins, it can be executed immediately. Now, a time lock ensures that there's public waiting period before anything happens, give everyone time to react if needed. And when the time comes, proposals will actually execute real actions like calling functions or other smart contracts automatically. So this isn't let's just vote, it's let's vote, validate, delay, and execute, the full real world flow that happens. Now, why is this a very huge step is You will learn how blockchain societies govern themselves. You will learn how systems like treasury allocations, protocol upgrades, features, changes, ecosystem fundings, all of this happen. And these are decided by not companies, but instead communities, enforced by very, very smart, unstoppable smart contracts. So you're learning how power gets distributed, how trust is shifted from people to code. You're learning how to build a system where no one needs permission. The rules are there, very clearly and automatically written and implemented for everyone to see. So now what we're going to build today is you will create a smart contract that lets anyone propose an idea after locking a token deposit. Let the community vote based on how many tokens they hold. Ensure a minimum number of voters participate. Again, that is the quorum management or balance we were talking about. Add a waiting period after the vote, which is time lock, and automatically execute the winning proposal actions if the vote passes. So all of it will be like fair, transparent, and trustless. So let's get started. Oops, I forgot an introduction. For everyone who stumbled upon this video randomly, or you were searching on how to write a DAO contract, how to build a DAO in Solidity, etc., and you don't know what this campaign is about, you can either go to the day one video where I talk about the entire campaign in detail, or you can head to web3compass.xyz. Here we have all the details about the campaign. It's day 28. I know day 27 is still not reflected. That's because the YouTube video is still pending. Day 28 is decentralized governance, and yeah, that's pretty much it. You can see all of these days. You can register with us whenever. You can hop on our Telegram group. We're happy to help. Now, what we're going to do is today we'll have to write 3 smart contracts. Basically, we're writing one and we are using the previous ones that we've already talked about. One is the governance token. So we're creating a governance token so that we can stake or deposit that in the DAO. There's another thing called fund transfer. I'll talk about it later. And then there will be a main file which talks about decentralized governance.so. Now, if anybody has noticed this, I have lost all my files of 30 days of Solidity. Very sad day for us because Remix was also not working yesterday. So day 27 was a mess entirely, but we are back again because we're not giving up. Okay. So let's just quickly copy this, paste it here. I hope you're able to see it. Yep. And what we'll do is we will import 3 things again: IRC20, Safecast, and Reentrancy Guard. Now, everyone who might have seen the Day 27 video, once it's out, you will get to know what these means, but you will definitely be able to see it by the time this video is released. So I don't have to explain it again, and I will say contract, decentralized governance is reentrancy, but not get out. Okay, great. So that's the first thing that we do. Now we'll get into thinking about what is the data that we need to process, state variables, mapping, structs, events, and then move to functions. But before that, just a quick thing about IRC20 interface. Again, this brings in the interface of ERC20 token so that you can make use of basic functions like transfer, transfer from, balance, etc., approve, etc. We use this so that our governance contract can talk to whatever ERC20 token is used for the voting power without caring about its full implementation. Safecast is basically a utility that helps with safe type conversions. So sometimes you need to convert UN256 and smaller types like UN32, UN64, etc. Without safety checks, bad conversions can lead to overflow or silent bugs. Now we've implemented this in yield farming as well, where we're talking about the token decimals. So for those conversions to be accurate and not really create any kind of bugs or loss of data, we use safecast, which makes sure that any number you shrink down won't lose any important data that is associated with it. Otherwise, the transaction will automatically revert. Again, reentrancy guard is the third import. This adds protection against a very nasty category of attacks called reentrancy attacks. We have talked about reentrancy attacks in detail. I think it's day 20 or 21. I think 20. It's the Fort Knox reentrancy guard. It was a very fun project that we really did. So you can look into that as well. A quick refresher on that one, that a reentrancy attack happens when a smart contract calls an external address before updating its own internal state, and that external address maliciously calls back into the contract and abuses any unfinished logic or any sneaky little mistake that you've done in terms of logic. So with the reentrancy guard, we can lock functions like execute proposal so that they can't be entered again before the first call finishes. Okay, so now since we've laid the foundation, we will say using safetest for UN256. Now this is saying, hey Solidity, anytime I have UN256, it gives me access to safecast functions automatically. It's like giving the UN256 variables extra superpowers, allowing them to safely downcast themselves to UN32, 64, or even UN8, or whatever is needed or required by that particular function or whatsoever that you're working with, without having to manually call the safecast major function each time. Now it leads to cleaner code and also safer math operations. Now it's time that we talk about core data. What are the proposal and voting records gonna be like? So for the heart of any proposal that we're using in a governance system, or we are proposing in a governance system, there's certain informations. We need to know what the proposal is about, who created it, how people voted, how many people voted on it, whether it passed to fail, what action should happen if it succeeds. So for that, the best case scenario is to use a struct. So we say struct proposal, and we'll say UN256 ID string description UN256 deadline. Okay. ID description deadline what? Okay, votes for this proposal. Votes against of this proposal. Okay. Is it executed? Who has proposed it? Then we're taking bytes data of execution data, like what happens if it is supposed to be executed, what are the execution targets, and then also what is the execution time that we're looking at. Okay, so now we have like an entire blueprint. ID is unique ID number of tracking, description again human readable explanation, deadline is a timestamp marking when the voting closes, votes for how many votes are casted in favor, then how many are against, executed, basically a boolean true or false value to track whether the proposal has already been executed. Proposer is the address of the person who created the proposal. Execution data is the actual data payloads to be called on other contracts if the proposal passes. Execution targets is the list of contract addresses that these payloads should be sent to. Like if there's an external contract that needs to be executed or whatsoever. And execution time is a future timestamp after the time log when the proposal can officially be executed. Okay. Now, this struct basically holds everything we need to fully manage our DAO proposal from start to finish, like from creation to voting to execution. Okay. Now this will set up, we need to set up mapping. So we say mapping UN 256 with the entire proposal struct, and we're saying public and proposals. Okay. Expected identifier. Oh, we're inside struct. Sorry, guys. Okay, great, right? So this sets up a mapping or a lookup table where each proposal struct is stored by its access or accessed by its unique ID. So think of it like proposal ID #2, this entire proposal struct. Right? Oh, Web3 Compass is doing an vibe coding campaign, an AI related campaign, or some other blockchain campaign. So yeah, it could be various proposals. Now the other mapping would be a double mapping, which is a little trickier but important. So we say the first key is supposed to be the proposal ID. The second key is to be the voter's address. Okay, and the next is the value is the simple bool value where we say 1 second, public has voted. So this lets us track whether a specific user has already voted on a specific proposal. Now it prevents double voting. It keeps the voting process very fair and clean. Now we have to set up some governance rules. So now that we've defined how proposals will be stored and tracked and executed, the next step is to set the rules that will control how governance actually works. Every DAO needs to answer a few important questions like who is allowed to vote, how long does voting stay open, who can create proposals, how many people need to participate in a proposal for it to be valid, etc. Okay, so then we'll write those rules. So we'll say, okay, IRC 20 public, there's a governance token, which we have already talked about when I showed you the ERC20 contract of governance token. Now we're saying there is a next proposal ID. Okay, then we're saying not three. Voting duration. Then we're saying UN 256. What else? Time log duration. Time log duration. Okay, great. Now, who is the admin? What else? UN 256 public quorum percentage, like how many people have to, or what is the percentage of people that have to agree or pass a proposal for it to be valid? And then what is the proposal deposit amount? Okay, great. So these are the rules again. This is one of the most important pieces of the whole system. Again, the governance token is the ERC20 token that represents the voting power. Whoever holds a token has the right to vote. The more tokens you have, the stronger you are. If you don't hold any governance tokens, you can't vote. Next proposal ID is keep tracks of the next ID that will be assigned when someone creates a new proposal. It starts at 0 by default. And then increments by 1 every time. Again, voting duration, time log duration, admin, all of this is self-understandable. For quorum percentage, again, minimum percentage of total votes that must participate for a proposal to be valid. So if quorum percentage is 5, then the total supply of tokens is like 10 lakhs, then you need 50,000 tokens, or 50,000 worth of tokens that must participate for that proposal to be valid. So without a quorum, a tiny group of voters could pass decisions unfairly, right? So we have to ensure that enough of the community is involved before big changes happen. And then proposal deposit amount is how many governance tokens a user must lock when creating a proposal. It acts as a spam filter, preventing people from flooding the system with random proposals without any consequences. So that's pretty much it. And now we will talk about events. So we're saying event proposal created 256 ID, a description, the proposal, who proposed it, and the deposit amount. Yeah. Okay. The next event could be voted. So then what proposal ID, address voter, who support. Wait. Now what we're missing here is great. So then we voted, then that could be proposal executed. So for proposal created and voted, everything is clear. There's ID, there's a description, who proposed it, what is the deposit amount. And for voted, we're saying which proposal they voted on, which address voted, whether they voted for or against, how much voting power, token weight they used, right? Now, similarly, we have proposal executed. So we say UINT 256 ID. Quorum needed. So we're looking at which proposal is supposed to be executed, what is the total number of votes, and what is the quorum needed. Actually, no. Why would we need the quorum? We just have to check the ID, and then we have to check if it has passed. Sorry, guys. Okay. Now we can look at an event which says proposal deposit paid. Okay, so we're saying there's an address proposer and there's an amount. Okay, now another thing could be proposal deposit refunded. Maybe somebody wants to take it back, or they're no longer interested to participate whatsoever, or maybe it did not go through, something like that. So address proposer, UINT 256 amount. We'll have to now create scenarios for these events to actually come into existence. Okay. So we're saying event maybe spelling is quorum not met. Okay, so here we will say, oh, there's a proposal whose ID is this, the total votes is this, and then the quorum needed. Oh, yeah. What else? Proposal created, voted, executed, deposit, paid, deposit refunded, quorum not met. Oh, time lock maybe? Time lock set. So there's a duration. Great. And event proposal time lock. So we say ID, which is the proposal ID, and then execution time. Great. These are all the events I could think of. Again, very, very straightforward. Deposit paid, great, deposit refunded. If a proposal passes and is executed, oh, when I was thinking of writing, I thought maybe somebody changed their mind on proposal. But actually, if the proposal passes and is executed, the proposer gets the deposit back, and this event logs that a refund is happening. So helps prove that winning proposals are rewarded. We are not doing any refunds if you change your mind. Then time lock set again. When the admin changes the time lock duration, the waiting period between the passing and the execution, this event basically announces the new time lock time, keeps governance again transparent. For time lock started, when a proposal wins the vote but enters the time lock delay before execution, this event announces that which proposal is entering the time lock and when exactly it will be eligible for the execution. Now, we will quickly write a modifier, only admin. Require message.sender admin missed message. Only admin can call. Great. So modifier is also done. Now you're basically protecting sensitive settings. Like certain things are supposed to be done only by the admin or the owner. So that is why to make sure that we use such modifiers. Now it's time to write the constructor. Okay. So we're saying address of the governance token, since we are going to deploy a governance token. Then there is a, oh my God. Then there's a voting duration. Then there's a time lock duration. Okay. So we say governance token is equals to IRC Yes, exactly. So we're saying we expect the deployer to tell us the address of the ERC20 token that will be used for governance voting. We save the token's address inside the contract so that we know where to check people's balances. We know which token gives user the voting power, and the lock-ins is what, this locks in which token controls the DAO. Okay. Now, voting duration is equals to voting duration. Again, number of seconds that each proposal will stay open for voting after a proposal is created, it will automatically expire with this much time has passed. Time lock duration is time lock duration. Again, mandatory voting time. This is between a proposal winning and it actually being executed again. So this protects users by giving them time to exit or reject to major changes before they are finalized. Now, we'll set the admin is equals to message dot sender. And then we say emit. Time lock is set and duration is what? Time lock duration. Great. So everything's transparent. Now it's time that we start writing the functions, and we will start with the smallest cute little functions initially. For example, the first thing that we're going to write is a function set quorum percentage quorum. Have I written the quorum percent? We're saying external only admin. Okay. Now we're saying require quorum percentage has to be less than equals to 100. Must be between 0 and 10. Again, we've set it as 5 initially, but we can give the users an option that, hey, it's time you choose anything between 0 to 10. And then we say quorum percentage is quorum percentage. Very simple. The function lets the admin change the quorum percentage, which is the minimum percentage of total tokens that must vote for the proposal to be valid. Only the admins can call this. That is why we have the only admin modifier. And the new quorum percentage must be between 0 and 100%. Ideally, it should be less than equals to 100. And otherwise, it reverts with an error. Once set, the new quorum percentage will apply to all the future proposals that we're talking about. Now, similarly, we will write a function set proposal deposit amount. So we say uint 256 proposal deposit amount. Okay. External only admin. Only admin. Okay. And we say proposal deposit amount is equals to proposal deposit. Again, only the admin can call this function because of the modifier. There's no range check here. The admin should set it responsibly depending on the DAO's need. If the deposit is too small, spam proposals could just flood in. If it is too high, it might just discourage participation. Now, similarly, we will do another only admin function, which is set time log duration. We say external only admin, and we say time log duration, and then emit time log was set, and then duration is basically time log duration. Okay, so again, waiting period. The waiting period between a proposal passing and it being executed, only the admin can call this. After we've set the new time lock or whatsoever, it will emit an event called time lock set to publicly announce the change. Very, very transparent. Okay. So now it's time that we start dealing with huge functions like proposal creation. Okay. So we say function create proposal. Okay. And we say, okay, the first thing is string call data description. Again, we're saving gas by not, if you use call data instead of memory, it saves gas. So, yeah. Then we're saying address call data targets. Again, maybe the address of the contracts that needs to be called once we have executed everything, right? Or once a proposal has passed. Then there's bytes, call data, call datas. Okay, now this might be very, very confusing. But since we are creating proposal, let's just do the easy part here. Call data. Okay, so the first section, again, we're saying string call data description is a short text that is describing what the proposal is about. The targets is the address of the contracts this proposal will interact with if it passes successfully. And the last thing, which seems a little confusing, is the actual function called data that will be sent to each target, like a function call packaged into bytes. Now we will see about it in more detail. Don't worry about it. Now we're saying, let's check a few conditions. Require governance token, okay, dot balance of message dot sender. Message dot sender, okay. What? Is greater than equals to proposal deposit amount? If yes, great. Otherwise, not enough governance tokens to create proposal. Fair enough. You should have enough deposit amount tokens that we're talking about, right? Now, what is it that we might need to check? Okay. So we have to require, like we have to check that the targets dot length is equals to call data's dot length. Okay, otherwise targets. So basically we are passing on the call data for the function that it is going to pass, and then there's a address of the targets, which is the target contract or the contract that will be executing once a proposal passes. So their length has to be similar. Targets and call data length is a mismatch. Okay, so this is done. Now, once you've checked this, you do governance.token transfer from. Again, you have to give permission from the approve, like from your ERC20 tokens contract address using the function approve for the DAO to actually take those tokens. Okay, transfer from message.sender, address this, and value is what? Proposal deposit amount. Fair enough? Again, now emit proposal deposit paid. Again, who's the proposer? Message. What is the amount? Proposal deposit amount. Great. Okay, now it's time that we start looking into data here. We have checked that the message.sender has enough balance of governance token to pay the proposal deposit amount. And next, we've made sure that each target contract must have one corresponding function call, which is called data. And we need to check to make sure that the lists are the same length. So this prevents execution errors later. And now we're transferring the proposal's deposit amount into the DAO contract. Then we emit an event announcing the payment. Now the system knows that the person who has proposed this particular proposal is very, very serious. So now we create a new proposal struct and fill it with its unique ID, like proposal ID and all of that. And I'll show you how to do that. So we say proposals. Next proposal ID is equals to. And then we say proposal. This is the best way. Okay, and then we say, okay, ID, next proposal ID, description, deadline, block dot timestamp plus voting duration, votes for 0, votes against 0, executed false, proposer. Proposer is message.sender, execution data is call datas, execution targets is underscore targets, execution time is basically 0. What is the problem? Proposer. There was a proposer. Oh, sorry. Proposer. So now this should be fine. Once you've done this, emit proposal created. ID is what? Next proposal ID. Description is what? Underscore description. Proposer is who? Message.sender. And deposit amount is what? Proposal deposit. Yep. Great. And then once you do this, you do next proposal ID plus plus return next proposal ID minus. Yeah, because we added an increment for the later, but we want to create a proposal, so we have to return the proposal ID, which is less than the value here, right? Great. Now what? We've created the proposal. What happens? Everything is clear. Input that is taking, how we're taking the deposit, how we're saving the new proposal, announcing the creation of new proposal, updating the proposal counter so that we increment the counter so that the next proposal will get its unique ID and then returns the ID of the newly created proposal. So this function is where the governance actually begins. It makes sure that only serious people can propose changes. Proposals are properly linked to real actions. Now it's time that we vote. So we say function vote uint 56 proposal ID, and then we say bool support. Right? And we're saying it's done. So we're loading into the memory. So we're saying proposal, storage, proposal. Again, we will take the proposal ID. Okay, great. Now we check the block.timestamp. Block.timestamp is less than proposal deadline. If yes, great. Otherwise, voting period over. Great. Other thing, require governance token dot balance of message.sender, okay, has to be greater than 0. Okay. No on this proposal. Great. We've checked 2 conditions here. This was proposals, right? What was the mapping? Proposals, yes. And we are saying proposal deadline. We're not really, sorry, it's proposal dot deadline. Yeah, reading it from the script. Okay, great. We've checked these requirement conditions. We'll also check if you have already voted so that there is no dual voting. Has voted proposal ID message.sender and then already voted for this proposal. Okay, oh my God, what is this? Okay, great. Now, can we just remove this? Okay. Now what we'll do is we will create or calculate the weight, like how much token or what is the weight of the proposal or the voting basically. Because everything is decided by how much token you hold, how long you have how long you have. Yeah. We'll calculate the weight here, where the more tokens you have, the more weight your vote carries. So bigger token holders have proportionally bigger influence. That is why we need to, calculate the weight. And then we say if support, okay, proposal dot votes for plus equals to weight, okay, else proposal dot votes against plus equals to weight. Has voted, proposal ID message dot sender equals to, and then you emit voted. So proposal ID is again proposal ID. The voter is the message dot sender. The support is support and the weight is weight. Okay, not added a semicolon here. Now what's happening? We're loading the proposal, okay, in like a temporary storage to check what the user wants to vote on. You have all the info. We have to make sure that the voting is still open. We have to make sure that the message or sender has enough governance tokens to vote, and that particular user has not voted already. To prevent double voting, we calculate the weight. Now we count the vote. Depending on whether user supports or opposes the proposal, we add their weight to the votes for or votes again. Every vote shifts the balance, and then we mark the user as voted. We record that this user has voted on this proposal. They can't vote again, keeps everything very clean and tap proof, and then we emit an event voted. So we broadcast. Okay. Now we have to finalize a proposal here. Okay. So we'll write a function for it. Function finalize proposal. Okay. UINT 256. Proposal ID external. Great. Now we will copy. So we'll check a few conditions, but this remains same. So we're saying we load the proposal in the storage, then we check block.timestamp is less than or less than voting less than proposal.deadline, so voting period is over. Then we check require proposal executed, proposal already exit. Okay, and then another thing is require proposal dot execution time is equals to 0. Actually equals to 0. So we say execution time is ready, set. Great. Fine. Now we will check for total supply. Total supply is governance token dot total supply with whatever we have created. UN 256 total votes. How many people have voted? So we say proposal dot votes for plus proposal dot votes against. Very simple calculation, right? Now we're saying quorum needed is equals to total supply into quorum percentage divided by 100. Makes sense. We've set it to 5% right now, right? So we say if total votes is greater than equals to quorum needed and proposal dot votes for is greater than proposal dot votes against, then what happens? We say proposal dot execution time is equals to block dot timestamp plus time log duration. That is how it's working. Very simple. And then we say emit proposal time lock started. Again, proposal, the ID would be proposal ID, right? And execution time is basically proposal dot execution. Okay, great. Otherwise, what happens if that condition is not met? Okay, we say proposal dot executed is equals to true, emit proposal executed, again proposal ID, this will be false. Okay, and then we're saying if also if total votes is less than quorum needed, emit quorum not met, again proposal ID. Votes total would be basically total votes and quorum needed is quorum needed. Okay, great. Everything's also deposit is not refunded for failed proposals, so that is why we are not doing any transfer here. Very simple. Load the proposal, make sure voting is over, make sure it's not already finalized, make sure it hasn't already entered time lock, calculate quorum, total votes, how many total tokens exist, how many votes were cast, how many votes were needed. If proposal passed and quorum met, so if enough people voted and most of the people voted for than against, then the proposal moves into the time lock period. The execution time is set to now plus the time lock duration, meaning it will be executable only after the waiting period. Again, this gives the community time to prepare for the change or respond if needed. And we emit an event so that everyone knows that the time lock has started. If proposal fails, that is either not enough votes or more votes against it, we immediately mark it as executed, so no further action will happen. Emit an event saying that the proposal has failed. If the problem was not enough voters participating, we emit an extra event called quorum not met to explain exactly why it failed. Okay. Now we also have to execute a proposal. So we'll write the function for it. We will now write function execute proposal, right? The parameter should be UN256, proposal ID. Oh, again, we're writing inside a function. That is why the error. Okay, great. So we make it external, and then we're also going to make it non-reentrant. Again, execution, so that because it's going to execute the proposal, we don't want any calls to happen while something is already in progress and all of that. So we will do proposal storage proposal equals to proposals and then proposal ID. Okay, then we check if the proposal is executed, dot executed, and we say proposal already executed. Great. Oh, comma. Yes. Great. Now, another condition that we have to check is regarding the execution time. So we say proposal dot execution time has to be greater than 0 and the block dot timestamp has to be greater than equals to proposal dot again execution time. Right? Now, if both these conditions meet, then we say time lock has not expired yet. Okay, great. Now what? Okay, now we set the proposal to true. So again, this is done or set executed early to just prevent re-entrancy to happen. Then we say bool passed is equals to proposal dot votes for has to be greater than proposal votes for has to be greater than proposal dot votes against, right? Obviously. So we say if passed, if passed. Okay, what we do is we run a loop. So we say for uint 256, I equals to 0, I is less than proposal dot execution targets dot length. I know it looks a little complicated, but I'll explain it all. And then we say I plus plus. Okay. What we do is write a bool success, comma, bytes memory, return data, and then we say proposal dot execution targets at I dot call proposal dot execution data at I. Wow, that is something. Okay, now what just happened here? After we have checked all the required condition, making sure the time lock is over, make sure that it has not already been executed, make sure that the proposal is set as executed before doing anything else, check if the proposal has actually passed. Now the execution comes in place. So if the proposal passed, we loop through all the target contracts. We call the corresponding function on each target using the stored call data. If any call fails, the entire execution reverts, okay, to stay consistent and safe. Now, this is where real changes happen, upgrades, transfers, new settings, etc. After successful execution, we will emit an event to mark the proposal as passed and executed. So we have to check, not targets. Okay, now here, because every time we use a dot call, we check it through a require statement if it's success and string data, because it does not have like by default thing return data, right? Great. And then once this has happened, we say just emit an event proposal executed and then proposal ID to true. Then what you do is take the governance token dot transfer again from the proposal. Read from the proposal. You have to read the proposer. Oh my god, these are confusing terms. And then deposit amount. And then what we do is emit proposal refunded, proposal.proposer, and proposal deposit amount, and that's it. That's all that we needed here. But this section again is if passed. Okay. Else what you are supposed to do is, else what you will do is just emit proposal executed proposal ID, and then we set it to false. Great. That is the if and else condition that we're talking about. And everything's pretty straightforward here. Okay. So now we will also look into getting proposal result. Okay. Then once we have done all the execution, how do we go about checking the result of it? Okay. Function get proposal result. Okay. We say uint 256 proposal ID. Okay. Again, external view returns. What will it return? String with memory with this. Okay, great. Now, again, few things remain the same. Okay. Okay, now what you will do is uint 256 total. Actually, we will just need this entire thing. So we'll not write it, save some time. Yeah, so we need the total supply, we need the total votes, we need the quorum needed. Okay, great. What do we do with this information? So we say if total votes is less than quorum needed, okay, just return proposal failed, quorum not met. Great. Very simple. Okay. Else if proposal, else if proposal dot votes for, yeah, for with proposal dot votes against, right? We say votes against, then we say return proposal passed. Great. Otherwise, an else condition, else return proposal rejected. Great. Very simple, straightforward results. We load the proposal, we make sure that it's already executed. Again, we can just check the opposite. Like both will work just fine. Yeah. Calculate total votes and quorum needed. If not enough participation with whatever conditions that you have, just pass it. Okay. And another very cute utility function, our code is not complete without utility functions. So we say get proposal details to view the entire proposal information. So we say proposal ID and we say external view returns. Again, what? Proposal memory. Great. And we just say return proposals. This is the mapping and the oh my god, this is such a tongue twister. I can't just, yeah, not 356, 256. The kind of mistakes I make, guys. Okay, so yeah, that's it, right? So this function will let anyone look up the full information about a specific proposal. You pass in the proposal ID, you get everything. Okay. Now, coming back to our governance token. Oh, this was our yield farming contract. Yeah. I recorded the entire thing. But anyway, let's close this right now. So now that we have written this decentralized governance contract, uh, as I talked about it in the starting of the video, that there will be a governance token. Then this was the segment fund transfer file that we've not talked about. Now, again, this file is just to be one of those target contracts that once you've, completed or voted for a proposal and it gets executed, then the particular function call would be done to this particular contract. So let's first compile and deploy the governance token. Okay. Yeah. So you deployed it. Now what happens is there are two things that you have to do here. Okay. So once you have deployed the governance token contract, it's time that you deploy the decentralized governance contract. Now, if you see here, you will see that there's a address of governance token from. So we will copy this address, paste it here, voting duration again 600 and let this be 300. Okay, time lock duration. Now you transact. Okay, so you've given the governance tokens address, voting duration, time lock duration, etc. Now once you deploy it with these values, each time that you approve the governance contract to spend your tokens, so you will go back to governance token contract and there is a approve, right? So we say we copy this address, the deployed address of decentralized governance, and with approve we are allowing the address of our DAO contract to spend those tokens on our behalf. So let me just approve 200 tokens. Okay, great. Okay, now we've done this. So we have the governance contract address added to the DAO contract, and then there's enough number of tokens to cover proposal deposit amount and maybe voting fees later. Okay, now we've created a fund transfer contract, okay, which basically lets us move ether. And this is something that you have to write on your own. There are just three functions that we're talking about, and one of them is utility function. So there's receive ether and then there's a withdraw option. Okay, now for withdraw, we can't check message.sender equals to owner because we will call it with the smart contract address, and in, approving, it's the DAO contract that's actually calling it. And once you deploy this, then it will take the account of this, right? So we just quickly compile fund transfer and we deploy it. Great. So we have the fund transfer section here as well. Now the thing is, if you come here and you see creating a proposal, right? So once you've created a target contract, it's time that you create a proposal. Now, there are three parameters that are required. Okay, one is description, one is targets, and one is the call data. Okay, now you will see that, for example, if you're creating a proposal to withdraw ether from fund transfer. Okay, so let's just add it as a description. Okay, great. Now, with address, what happens is that you can see that it's an array. Okay, so there's an array. So we would just copy this fund transfer contract and we will paste it here. Again, now it's in quotes because it is going to represent the array element, a single array element. And in order to get the call data, which was again a bytes data type, where is it? Where did we write create proposal? Okay, yes. So there's bytes array of call datas. Now what happens here is that once you compile, there is an ABI section. If I had to show you this, it would be something like this, right? Now, ABI is application binary interface. It has all the functions and all of that we're talking about, variables and all of that stuff. So here there is a, where is it? Proposal deposit amount. Next proposal, right? Oh my God, I have just lost it. I can actually just find it. Oh, that's a long ABI, by the way. But with come on, did we copy it for transfer? Okay. So then what we do is we write a script here which says const ABI for function withdraw ether. Then we're creating a interface here and then we're fetching the data, and this is the bytes data that we're going to get. So once you run this here with a control shift plus S, you will get a value here. Okay, this is the bytes data that we're talking about. Okay, so what we do is we copy this and we say double quotes. Okay, we paste it here as a bytes call data and we transact. Great. Now, once you've run the script, copy the bytes count, and now you've created a proposal, it's time that you vote on your proposal. Okay. So now what happens is, if you check next proposal ID, it will be 1 because it is index 0, a proposal deposit amount, quorum percentage, time lock, voting duration, all of it. So you can just check it, but we will come to vote. We are saying proposal ID 0 and then bool, like we are in favor. So we will say true and you transact it. Great. So now once you have done that, it's time for voting to end and finalize. So that is when you call the finalize proposal ID and we say 0 and you transact it. Great. It goes through. So the checks, if passed, meets quorum, schedules it for execution, and it will set an execution time after the time lock duration. So we have to wait for time lock and then execute, and then you will see that the governance contract will call the withdraw ether. So in the meanwhile, because we've sort of put the time lock duration as 300 seconds, that's like 5 minutes. So what we will do is, okay, this is decentralized governance and this is fund transfer. So what I'll do is I will put myself 5 ether here in a fund transfer so that you can sort of, once this is called, you can see it happening. Okay. And with the current balance, we have 94.99. Okay. Get balance, who's the owner, so this person is the owner, received, how much, this, right? Everything is fine. Even for this, it's the governance token. You can see transfer from, allowance, balance of decimals, name, symbol, total supply, blah, 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 all of it. Now, if you come back to the DAO contract, and if you want to sort of, one second, execute proposal ID. So right, that it will wait for a certain time. So it will give you the time lock has not expired yet. That means we've not passed a 5 minutes yet. That is what we gave as the value. Okay. So let's check that whether the time lock duration has expired or not, because we have discussed this a lot number of times, that once you voted for a proposal and you've finalized it, it will, if all the conditions are met, the quorum is met and all of that, it will set an execution time after the time lock duration is completed, because that is when you click on finalize proposal, and for any changes to be implemented before it's finalized, a team discussion or the community decision making and all should happen, right? So we will try finalize proposal again. So it says execution time is already set. That means time lock duration was expired and then there was execution time, right? Now what happens? You go to execute proposal and you continue it, and here you say that the fund transfer it as 0 ETH, and then you're back at 99.99, right? So once the proposal has been accepted. Now, this was me doing everything from my account, but you can have multiple accounts to vote for it. All you have to do is give some tokens, okay, as amount. So once this proposal happens and it's executed, the target contract here was the withdraw function, and we've given the ABI. That is how smart contracts interaction is happening. So you give targets and then you give the call data's value, and boom, you don't need to do anything. It's automatic. So all the rules are set. Everything is coded. So from creating a proposal to voting to finalizing to executing, everything is done. Okay. So let us know if you would want Web3 Compass to be your DAO, and maybe one of you could create it. So now, anyway, now you have a full decentralized decision making with on-chain execution. So you didn't just like vote like normal people, you governed, you proposed, you voted, and you executed a real on-chain action. Yeah, that's pretty much it. Till then, happy building. I will see you for day 29. Bye, guys.